So here's one more example of shells. This time we're not going around the y-axis, but we're going around another vertical line. Shells are really good when you're going around vertical lines because the setup is so easy. In this case, we're again using 2 pi. The 2 pi is actually the most common thing that people forget. From a to b, and then it'll be r times h, and then we'll have a dx. So in this particular case, we'll have 2 pi. And then we can see by looking at it that the region over which we're going to integrate, the area, or the radii, are from 0 to 1. So that's going to be our bounds on integration, 0 to 1. And now what we need is the radius. So let's see, again I'm going to add a kind of representative little like cross section of a shell. That's what it would look like. And what we need to do is we need to figure out as it rotates, so the radius for this particular one would go from here to here. And you can see, if you think about it, the radius is really a distance. So in this case, it'll be 2 minus x. And then what some people have difficulty understanding is that this x can be any value between 0 and 1. And if you think about that, you know, if x is 0, we would get a radius of 2, which is good. If x is 1, we would end up with a radius of 1. So that actually covers every radius that we want. We want every radius between 1 and 2. We don't want anything that's between 0 and 1, but from 1 to 2 is what we're looking for. So that's why this works out to the radius. The height is going to be the top curve, which is this cubic thing, and then minus the bottom, which is just 1. So that actually works out to just being x cubed plus x, because the plus 1 and then the minus 1 gives us that. So dx. And that's the setup. And again, I'm going to pause this here and work it all out, and then I'll come back to the video and show you my solution so you can compare. So try it on your own. I'll be right back. Okay, so here's my solution, and you can do your comparisons. And what I did was I just expanded this, then kind of reverse the power rule, and then substitute in. When you substitute in 0, everything goes away. So really you just need to worry about that, and then simplify down to get that. So that's the volume. And you can actually see, if I took the axis of rotation and put it somewhere over here, what would have changed about my setup is that instead of having 2 minus x, so let's say that my axis was at -2, well, then my radius would have become x minus -2 or x plus 2. So what you do is you just choose it so that the distance for the radius is a positive value. So basically if the axis is to the right of the region, you're going to do the axis minus x, and if the axis is somewhere to the left, you're going to end up doing x minus the axis. Okay, so I hope you find that helpful.